Hello viewer, welcome to our chemistry lesson, and don't forget that we have been dealing with electrochemistry. This is now lesson number 4. This is now lesson number 4. If you are in school, you will be able now to be knowing that this is actually almost the last lesson. So we still have one lesson in this week for our presentation. Now, I want to say this before I continue. Now, we know that we are facing a very great problem which is affecting the entire universe or the entire world. So I want to appeal to you that you stay at home, stay safe, save yourself and save the whole nation. Stay at home. Me, I'm at home. And I'm running these lessons to you. So that if you are at home, you can still get this lesson when you are at home. Because basically, this is what we have been doing in our classes. We have been actually taught to embrace ICT. So this is not something new to us that we are using ICT. We are using ICT maybe now because we are not in school because of the problem. So we are now outside the classroom, but we can still actually meet. And the advantage of this, we can meet more learners as we have in our normal class, which is actually around 40 to 45. Now, so today, we want to actually still go further and look more about electrochemistry. And look more about electrochemistry as our topic that we have been tackling. So, I hope you have followed our lessons from our YouTube channel, and you actually we are going to get that we have won a step. Now, the objective of our lesson today, is actually the learner should be able to describe how a half cell is. A half cell is formed. A half cell is formed. Now, we are looking today at the part of the half cell. Part of a half cell. Now, this is actually the half cell. What is this half cell? What is this half cell? Maybe you'll ask yourself. Now, let's basically look at the chemistry behind the formation of half cell. Let's look at basically the formation of half cell. Now, this one, we are going to look at this topic called electrochemical cell. Electrochemical cell. Electrochemical cell will actually lead us to the formation of half cell. Now, let's look at this. Now, if we have a metal and we have a solution of that metal, do you know that? We are saying if we have a metal, for example, zinc. Now, and you have a solution of that zinc. Now, let's say zinc sulfate. Now, when a metal rod is put into a solution of its ion, its own ion, or actually salt, some of the metal ionizes. The meaning of ionization here means it dissolves. It gets into the solution. And therefore, we have now that metal rod will lose the electrons. The metal rod will lose the electrons. Now, this metal rod, when it loses the electrons, basically, let's take for example, we have a monovalent metal. Monovalent metal, it's actually losing electrons to give us the what? To give us M positive plus 1 electron. That's actually a monovalent metal. And then if we have a divalent metal, we have that losing electron. In this, the same solution, it actually becomes 2 positive and give us 2 electrons. We also have a divalent metal, whereby it loses 3 electrons, and it actually renders to be a trivalent metal. So therefore, the ions move into the solution. We have those ions now moving into the solution. It moves into the solution, leaving electrons on the surface of the metal. Remember, if the ions now are moving, these ions here move into the solution. Why? Because the ions, these ions here are the same as the ions in the solution. If we have zinc, it is going to be zinc. Now, the zinc now will mix together. But don't forget this, the electron will stick on the surface of the metal plate or metal rod. Now, we are saying that number 2, the metal rod becomes therefore negatively charged. Now we have the accumulation of electrons. Here. This one, it becomes negatively charged, while its solution becomes positively charged, because now ions, they are positive, moves into the solution, and now the electrons, which are actually on the surface of the metal, becomes actually negatively charged. As the positive charges of the solution increases, okay, some of them recombine with the electron to form back the metal. So we are going to see that at the end of the day, maybe this one will combine back to form the same metal. Consequently, an electric potential difference is created between the metal rod and the positively charged ion. So we'll have actually a potential difference, because now potential difference is actually created when we have now a difference. We have positive ions and negative ions. This one now will give us a potential difference. Now let me just use this diagram to actually let you understand. This is a solution. I hope it is clear. This is a solution. Now, when this metal now it's going to ionize, it's going to dissolve. When it is dissolved, these electrons here, this dashes here actually represent the electrons. It represents the electrons. So the electrons actually will again accumulate here. Now, now the ions will actually get into the solution. The ions will get into the solution, and therefore that is actually what we have as the half cell. Now, basically, this one is having the following components. We have the metal rod and we have the solution. We have the metal rod and the solution. That actually composed of the half cell. Composed of the half cell. Now, number 3, when a metal rod is put in a solution of its own self, it constitutes what we call half cell. If we have a metal rod like this one now, like this, you dip into that. This one consists of half cell. Why? Because we have a metal of its own ion, which we have its solution here. It's actually make up what we call the half cell. That is the half cell. It's not actually a complete cell. Now, when you have a complete cell, then it is actually going to be something else. It's actually going to be something else. But I want you to understand that we have a half cell is composed of a metal rod and a solution of its own ion. Now, that is basically for that. So we are saying the tendency of metals to ionize differ from one metal to another. So you know that even human beings are different. So also God has made these metals to be different in the way they operate. So they are different ionization, or the process in which they dissolve to get into the solution varies. How we are going to see how they are going to vary. We are going to learn more about how it brings in variation. So that is actually basically what we have learned. The difference can be measured by connecting two half cells to form an electrochemical cell. So basically, if we have a half cell, two half cells, we connect them. How do we connect that? We are going to see in our next lesson. But today, that marks the end of our lesson. I want to remind you also that to subscribe at Mwalimu Sitonic. Subscribe at Mwalimu Sitonic. And don't forget, stay at home, stay safe, save yourself, and save the entire nation. May God bless you, and let us meet next time when we'll be having our next presentation. God bless you. Thank you.